Hello everyone, this is Pooja. Welcome you all to my Elite Academy YouTube channel. फ्रेंड्स, ऑलरेडी आपण पॉवर सिस्टम 2 चे व्हिडिओ लेक्चर स्टार्ट केलेले आहेत. त्यात युनिट नंबर 1 परफॉर्मन्स ऑफ ट्रान्समिशन लाईन याचं फर्स्ट टॉपिक क्लासिफिकेशन ऑफ ट्रान्समिशन लाईन ऑलरेडी मी माझ्या एलिट अकॅडमी यूट्यूब चॅनलवरती पोस्ट केलेली आहे. त्याची लिंक मी खाली डिस्क्रिप्शन बॉक्समध्ये दिलेली आहे. जर अजूनही कोणी ती व्हिडिओ बघितली नसेल तर प्लीज डिस्क्रिप्शन बॉक्समध्ये जाऊन तुम्ही त्या व्हिडिओ बघू शकतात. चॅनलला जर अजून सबस्क्राईब केलं नसेल तर नक्की सबस्क्राईब करा. आज आपण युनिट नंबर 1चा नेक्स्ट टॉपिक बघणार आहोत, पॉवर फ्लो थ्रू ट्रान्समिशन लाईन यूजिंग जनरलाइज कॉन्स्टंट्स. Before starting with the derivation, what do you mean by the generalized constants of the transmission line? So here we use two-port network equation for the analysis and calculations of transmission line. In two-port network equation, there are four variables. Two are on the input side and two on the output side. हे जे टू पोर्ट नेटवर्क इक्वेशन आहे ते तुम्ही नेटवर्क ॲनालिसिस या सेकंड इयरच्या सब्जेक्टमध्ये तुम्ही ऑलरेडी शिकलेला आहात. तेच टू पोर्ट नेटवर्क इक्वेशन आहे. फक्त आपण ते टू पोर्ट नेटवर्क इक्वेशन जे आहे ते ट्रान्समिशन लाईन करता आपण बघणार आहोत. तर ट्रान्समिशन लाईनमध्ये तुम्हाला रिसिविंग एंड असतं आणि एका साईडला सेंडिंग एंड असतं. सो असे दोन पॉईंट्स असतात. या दोन्ही पॉईंटवरती दोन दोन व्हेरिएबल्स असतात. ॲट द रिसिविंग एंड साईड वी हॅव अ VR and IR. This VR is a receiving end voltage and this IR is receiving end current. At the sending end side we have a VS and IS. VS is a sending end voltage and IS is a sending end current. Now the two port network equation can be written as VS is equals to AVR plus BIR and IS is equals to CVR plus DIR, where these A, B, C and D are the generalized circuit constants of the transmission line. These A, B, C, D are the generalized circuit constants, where A is a dimensionless and B is having a unit ohm, and always remember it is always related with the impedance Z, where C is having a unit Siemens and it is always related with the Y, that is admittance, and where D is also dimensionless quantity. हे जे आहे हे तुम्हाला ओरलमध्ये विचारलं जाऊ शकतं. व्हॉट आर द युनिट्स ऑफ ABCD generalized circuit constants? So A and D are dimensionless, B ohm and C having Siemens unit. Let's start with our derivation, power flow through transmission line using generalized constant. This is very important derivation. Okay, for that let's draw figure, a two bus system. This is generator. Okay, at the receiving end here voltage VR, at sending end voltage VS at an angle delta. As loads are expressed in watts or kilowatt and reactive power is in VAR or kVAR, it is convenient to deal with transmission line equation in the form of sending end and receiving end complex power and voltages. Let us take VR is equals to mod of VR at an angle 0 degree. This is receiving end voltage as reference phasor. Reference phasor है, that's why angle is 0. VS is equals to mod of VS at an angle delta. This is sending end voltage leads VR by angle delta, where delta is equals to torque angle or load angle or power angle. Here SS is the sending end complex power, which is given as PS plus JQS complex power. Therefore here PS plus JQS. Here real term and imaginary term, which is active power and reactive power. It can be also written as VS into IS conjugate. This is our equation number 1. Next is a SR, receiving end complex power. It can be written as PR plus JQR is equals to VR IR conjugate. This is equation number 2. Now, sending end and receiving end currents can be given by solving two-port equation of transmission line. Already we have seen the two-port equation of transmission line. Vs is equals to A VR plus B IR and Is is equals to C VR plus D IR. From this equation, we have to find out the sending end and receiving end currents, means Is and Ir. We have to find out Is and Ir, right? So rearrange these two equations. We will get the Ir and Is. By rearranging this equation, Ir is equals to what? Vs minus A VR upon B. This is Ir. This can be written as 1 upon B Vs minus A upon B VR. Now substitute this IR value in this equation. What we will get? Is equals to, solve this total term, this VR and this VR, take common, do cross multiplication over here. But we know AD minus BC is equals to 1. Therefore, BC minus AD is equals to minus 1. हे अपोजिट केलं तर काय येणार आहे? minus 1. Therefore, instead of this, we can write down minus 1. Therefore, minus 1 upon B. This is equation for Is. Okay, so we got equation for Is and equation for IR. Now let the transmission line constants can be written as, आता हे जे सगळे ट्रान्समिशन लाईन कॉन्स्टंट्स आहेत A अपॉन B, 1 अपॉन B, हे जे A B C D जे ट्रान्समिशन लाईन कॉन्स्टंट्स आहेत हे आपण मॅग्निट्यूड आणि अँगल या टर्ममध्ये लिहिणार आहोत, बिकॉज वी हॅव टू फाइंड आउट द कॉम्प्लेक्स पॉवर, active power and reactive power, right? That's why we will write down all these terms in the magnitude and angle format. So A is equals to magnitude of A at an angle alpha, B is equals to mod of B at an angle beta, D is equals to mod of D at an angle alpha. We can write down equation number 3 and 4 as, now we have to write down this equation number 3 and 4 in terms of this magnitude, and also at the starting we already write down this Vs is equals to mod of Vs at an angle delta and Vr is equals to mod of Vr at an angle 0. So write down this 3 and 4th equation in terms of these magnitudes. How we can write down? Equation number 3 can become Ir is equals to 1 upon B mod of B at an angle beta. This equation number 3 becomes this. आता हे जे अँगल आहेत हे डिवाइडमध्ये, जेव्हा अँगल डिवाइडमध्ये असतात तेव्हा त्यांचं आपण काय करतो? सबस्ट्रॅक्शन करतो, आणि जेव्हा मल्टिप्लिकेशनमध्ये असतात तेव्हा त्या अँगल्सचं आपण ॲडिशन करतो. सो दिस IR becomes 1 upon mod of B mod of Vs at an angle delta minus beta minus mod of A upon mod of B mod of Vr alpha plus 0 alpha, and this डिवाइड मध्ये बीटा आहे म्हणून हा काय होईल? मायनस बीटा. सिमिलरली फॉर Is हे काय होईल? मॉड, फक्त इथे याचा अँगल काय लिहिला आपण? ॲट अन अँगल अल्फा, याचा अँगल ॲट अन अँगल बीटा, याचा अँगल at an angle delta, right? So alpha plus delta minus beta, याचा अँगल ॲट अन अँगल बीटा आणि याचा अँगल 0, त्याच्यामध्ये 0 मायनस बीटा मायनस बीटा. So we got these two equations for IR and IS. Now what we have to find out? Power काय आहे? PR and reactive power काय आहे? QR at the receiving end side and at the sending end PS and QS, right? We have to find out these terms. So for finding out these terms, we need to solve equation for SR and SS. So in the starting, equation number 1, what is that? SS is equals to PS plus JQS, which is equals to VS IS conjugate, and receiving end complex power is equals to VR IR conjugate. So now we have the terms for IR and IS, right? So we can substitute those values in this equation number 1 and equation number 2, and we can find out the equation for SR. From that we can find out PR and QR. So let's substitute the values of these IR and IS in equation number 1 and 2. What is our equation 2? SR is equals to VR IR conjugate. So we know value for VR, mod of VR at an angle 0. What is IR? Having a conjugate. जेव्हा कॉन्जुगेट असतो तेव्हा अँगल्सचे साइन चेंज करायचे. सो mod of VR and this angle is in a multiplication, so it will get added. So mod of VR into mod of B, mod of VS, open these brackets, what we will get? So this is equation number 3, which is SR. We got SR. Similarly, we can write down the equation for SS. This is equation number 4. Now in these two equations, the SR and SS both are per phase VA values, but if this VR and VS are in kilovolt, means kV, then the three phase receiving end complex power is given by, म्हणजे जर ही VR and VS केवी मध्ये असेल तर आपण काय करणार? 10⁻³ नी मल्टिप्लाय करणार, राईट. आणि 3 फेज मध्ये आपल्याला हे इक्वेशन डिनोट करायचं असेल तर ते कसं आपण डिनोट करणार? लेट्स सी. SR 3 फेज VA इक्वेशन इज इक्वल्स टू 3 फेज म्हणून 3 into VS mod of VS mod of VR upon VS चा एक √3, VR चा एक √3, mod of B into 10⁻⁶. किलोवोल्ट आहे म्हणून याचा 10⁻³ याचा 10⁻³ दोघांचा मिळून किती झाला? 10⁻⁶. ॲट अन अँगल बीटा मायनस डेल्टा मायनस मॉड ऑफ A अपॉन B VR स्क्वेअर अपॉन √3 चा स्क्वेअर. इथे काय येईल? √3 चा स्क्वेअर, राईट, इंटू 10⁻⁶. ॲट अन अँगल बीटा मायनस अल्फा. So √3 into √3 it becomes 3. √3 चा स्क्वेअर 3. हा 3 टोटल ब्रॅकेटला मल्टिप्लाय. दॅट्स वाय this and this will get cancel, राईट. देअरफॉर आणि हे 10⁻⁶, 10⁻³ असेल तर आपण काय म्हणतो? केवी. 10⁻⁶ असेल तर काय म्हणणार? MV, राईट. सो ही पॉवर आहे त्यामुळे आपण इथे काय म्हणणार? देअरफॉर SR 3 फेज MVA is equals to, this is your equation number 5. Now from observing this equation number 5, we can say that equation number 3 and 4 represents the three-phase MVA if Vs and Vr are expressed in terms of a kV line. But what we have to find out, the active power and reactive power at the receiving end side, right? So receiving end side active power is a PR and QR. हे कशावरून आपण फाइंड आउट करू शकतो? SR is equals to PR plus JQR. This is active power, this is reactive power, right? So आपल्याकडे SR चं इक्वेशन आहे. This is, from that we can write down the equation for PR and QR. आता सिंपल वे PR चं इक्वेशन म्हणजे ॲक्टिव्ह पॉवरचं इक्वेशन लिहिताना ऑलवेज रिमेंबर दिस angle sign will get changed by cos, and in case of a reactive power, angle sign in case of a reactive power changes by sign. Okay, so simply PR चं इक्वेशन कसं येईल? Vs, this is your active power, and reactive power, how we can write down the reactive power? QR is equals to, फक्त या अँगल साईनच्या ठिकाणी काय लिहिणार आपण? साइन. बाकी इक्वेशन सेम. Vs, this is equation number 7, reactive power. Similarly PS आणि QS चं इक्वेशन तुम्ही लिहू शकतात. Now this PR will become maximum value when PR max कधी होईल? When this beta and delta becomes equal, right? हे बीटा and delta जेव्हा सेम होतील तेव्हा काय होईल? Cos of 0 होईल, and cos of 0 is always equals to 1, and therefore this PR gives us a maximum value, that is Vs. This is equation number 8. आता याच कंडिशन मॅक्झिमम व्हॅल्यूच्या कंडिशनवरती तुमचा QR ची व्हॅल्यू काय असेल? तर ह्या QRच्या इक्वेशनमध्ये आपण काय सबस्टिट्यूट करणार? बीटा इज इक्वल्स टू डेल्टा. इथे बीटा इज इक्वल्स टू डेल्टा सबस्टिट्यूट केलं तर साइन ऑफ 0 इज इक्वल्स टू 0. देअरफॉर ही टोटल टर्म काय होईल तुमची? 0 होऊन जाईल. मग राहील काय? फक्त दिस टर्म. देअरफॉर QR is equals to minus. This is equation number 9. Now consider the special case of a short line. शॉर्ट लाईन करता PR आणि QR याचे इक्वेशन्स कसे फॉर्म होतील ते आपण आता बघूयात. ओके, विथ द सिरीज इम्पिडन्स Z. These are the generalized constants for short line. Substitute these A, B, D values in our PR and QR equation. We already have the PR and QR equation, 6th and 7th equation. So here alpha is equals to 0 and beta is equals to theta. A will get replaced by 1 and B replaced by Z. ओके, सिम्पली हे जे PR चं इक्वेशन आहे यामध्ये हे सबस्टिट्यूशन करायचं आहे. तर आपलं PR चं इक्वेशन कसं होईल? अँड सिमिलरली द QR इक्वेशन बिकम्स, how we will get PR max at which condition? When this theta equals to delta. But normally for the short line the resistance is small, very small as compared to the reactance. It is necessary to maintain high efficiency and therefore the resistance is very small as compared to the reactance. And we know that Z is equals to r plus jx. So theta is equals to what? Tan inverse of x upon r, imaginary upon real, which is equals to 90 degree. Substitute this theta value in this equation number 10. What we will get? Now we know that cos of 90 minus delta is equals to sine of delta, and cos of 90 is equals to 0. Therefore हे इक्वेशन कसं होईल? This equation number 12. Similarly, write down the equation for QR. So we know that sine 90 minus delta is equals to cos of delta, and sine 90 is equals to 1. Therefore this equation becomes, this is your equation number 13. Now in both the equation number 12 and equation number 13, here this is our equation number 12 and equation number 13. Already we know that r is very small than this x, therefore r is neglected. Therefore we can say that z is equals to x. Therefore substitute in this equation PR. This delta is very small angle, therefore it is approximately equals to 0, and therefore cos of delta is equals to cos of 0, which is equals to 1. Therefore this QR is equals to Vs VR upon x minus mod of VR square upon x. So from this, take this VR common, but we know that this mod of Vs minus mod of VR represents the voltage drop. This is what? Voltage drop. Therefore we can write down VR upon x, voltage drop, mod of voltage drop. So this is your equation number 14. Now we got all these equations. So from equation number 14 and equation number 15, there are some conclusions. First conclusion is, for r is equals to 0, म्हणजे आपण r जे रेजिस्टन्सची व्हॅल्यू जी कन्सिडर केली आहे 0, in that case PR is proportional to angle sine delta, right? This PR is proportional to this sine delta, and QR, this reactive power, is proportional to the magnitude of voltage drop. Second assumption is PR is maximum at angle delta is equals to 90, and the formula for that is PR max is equals to mod of Vs mod of VR upon x sine delta. This delta is equals to 90, means sine 90 is equals to 1, and therefore PR max is equals to Vs VR upon x. This is very important. Next conclusion is, this PR max depends upon this x, but we know that XL is equals to 2 pi FL, right, where x is directly proportional to inductance. Therefore as inductance reduces, the line capacity increases. And the last conclusion is, this QR does not have any delta value. QR does not depend upon angle delta, only depends upon magnitude of voltage drop. आय होप सो तुम्हाला सर्वांना आजचं हे डेरिवेशन समजलं असेल. कोणाला काही डाऊट असेल तर प्लीज कॉमेंट सेक्शनमध्ये लिहून नक्की कळवा आणि माझ्या यूट्यूब चॅनलला नक्की सबस्क्राईब करा. थँक्यू.